Shall I go into the zone? Hi, welcome back everyone after that coffee break. I'm really delighted to introduce this industry session. The idea is that we hear from a number of the, well, only a small subset really, of all the different people who have various startups, spin-outs, initiatives, commercial enterprises who are using category theory. Maybe they have success stories, maybe they have horror stories, maybe they have interesting anecdotes, maybe they have some cool science to tell us about. It's up to them, and I hope that we can hear lots of interesting stuff and maybe have a little discussion at the end. That would be great. So up first is Philip Wadler. Philip, are you there? Could you
Hello.
Hi, we can see you. That's great. So Philip is a professor at the University of Edinburgh, and he has various industrial connections as well, IOHK, I think. Phil was involved in one of the first applied category theory initiatives, which is understanding the structure of monad and what that means as something that can be applied to the theory of programming languages. And I said to him that we'd be really fascinated to hear his experience, but also maybe particularly, I don't know if that's something you want to tell us about, but in particular, the history of that how that came about, right? What do people say culturally when you went to computer scientists in the 80s and you said, hey, there's this thing called category theory and there's this thing called a monad? And what were those, I'd be fascinated, what were those conversations like? Were people receptive? I can't particularly imagine that they were receptive, to be honest. Anyway, over to you, Phil.
Right. So first of all, thank you very much for inviting me. Second of all, my apologies, but I'm going to have to leave after about half an hour because I've got a conflicting appointment. So I'm sorry that I'm not going to be with you for the whole session. Third, apologies because I don't really have that much to say. I mean, when I was asked to do this, I thought, oh, what can I say about, oh yeah, there's monads. So I was involved, everything in research is a chain, right? So I was involved with monads. I was the sort of the next link in the chain after Eugenio worked out how to apply monads to programming language semantics, which was the next link after various category theorists came up with the ideas and so on. So there's always links in a chain that you could apply. And then it really feels very much like being a link, right? The only reason that you guys care about what I have to say about this is that afterwards, other people picked up that idea and ran with it. So like at the same time, I was also working on type classes, which were just a way of supporting sort of reconciling ad hoc polymorphism, right? Plus means one thing on integers and a different thing on floating point numbers with parametric polymorphism, sort of bringing those two things together so that you could sort of define an algebra for whatever your data type was, and you could have a fixed algebra and then change the data types underneath it, and that would work reasonably well. And so that turned out to apply very neatly to monads. So it became very easy for people to have a type class for whichever monad they were working with, which let them then just say, well, okay, well, I need something with a set and a get, and you could put in various monads that had a set and a get. But the reason that all that worked was because Mark Jones came along and generalized type classes to be higher order. I only had type classes over types, whereas Mark worked out how to have type classes over things whose kind was type to type or what have you, which was, of course, then brings in monads, which are, among other things, are a function or a functor from types to types. So it's very important that you've got a chain of these things. With regard to how people reacted to it being category theory, I kind of tried to hide that in that, I said it was category theory, but I very much tried to write my papers so that you didn't need to know any category theory to read those papers. And that was probably an important step in those ideas catching on. Now, despite that, I got a lot of flack from people saying, oh, this is way too hard. And one of the specific things they pointed to was calling it a monad. They just said that was a very bad idea. I think it was Simon Peyton Jones who came up with saying, well, we really should have just called them warm fuzzy things. and that would have worked much more effectively. So there is something to be said for trying to pick your terminology in a way that doesn't scare people off. What's also true is I've read things now from people who are developers saying, functional programming is just too hard because you have to learn category theory first. I'm quite surprised that some people think that, but some people do. And again, that's maybe, while saying all the good things that you can do with category theory, I think maybe that's a message we should avoid giving. I see lots of hands up, which is great. What I plan to do is to speak for a very short time and then answer questions. So if it's okay, James, could I just use the rest of my time for answering questions?
Yeah, of course. I think maybe those hands aren't all questions. There might be people who are speaking later in the session and they're raising their hands to mark that for that reason. I really like this idea of the chain, right? I mean, we can't, there's obviously a spectrum from pure to applied, and most of us can't be at every point on that spectrum, right? But we can try and take ideas from the pure end and pass them down further down the applied end. And of course, we can go in the other direction as well. Do you feel that you enjoy being at different places in that chain, or do you feel you have a place that you like being in that chain, maybe towards one end and the other? What capabilities or skills do you need as a researcher to work profitably as a link in that chain?
I think everybody can work in link the chain. Yeah, the part of the chain that I enjoy being in is studying the theoretical stuff that all the people at this meeting who are much more clever than me do, and trying to turn that into simpler stuff. One problem that I have in general as a computer scientist is there are a lot of computer scientists who are very, very clever. And of course, that's great. They can do amazing things. But I want to make an argument here for stupidity. I think stupidity is also important. And in particular, the problem with people who are really, really clever is they can do things that are really quite complicated. And so we need the stupid people to come in, that's me, and to say, okay, how can we make this simpler so that stupid people can do it?
So nobody
both, of course. I don't want to tell the clever people to stop.
So you're not fooling anybody. You're not fooling anybody that you're stupid. But I guess the point is that maybe the aspects of what we do in the more theoretical end, the aspects that are going to be ultimately successful in making their way into applications, they aren't going to be the fanciest curlicues of the theory. They're going to be the simple, basic robust building blocks. Hello?
Well, you find the things that can be used to do something useful. That's very important, I think. So like I see Chad Nestor is one of the people attending. He did some really, really nice category theory related to IOHK about what would be a categorical description of a resource that's being passed around linearly.
Do you want to say a little bit about IOHK and what that is, and what the role that you see as category theory playing in that as a sort of research lab?
Sure. So IOHK, they're changing their name, I think, to IOG, but they're a cryptocurrency firm. They have a cryptocurrency called ADA. They are proof of stake rather than proof of work, which means it's much less energy to do a transaction with the cryptocurrency. They also have native support for whatever tokens you want, which means you can create your own token on the system very easily. And in particular, it means you can create unique tokens, what are called NFTs, non-fungible tokens, very easily. They're, I think, third or fourth by market capitalization at this point. And the two things I would say about IOG to recommend them to anybody, lots of people think, it's cryptocurrency, it's a scam. Many cryptocurrencies are scams. Not all the ones out there are scams. IOG, I think, there are two things about them that I really like. One is that they have written a lot of their software in Haskell. And the other is that they are committed to everything they do being published open source and being published open access, and in particular being peer reviewed. And this doesn't surprise any of us, right? Everything we do is peer reviewed, except this is a company. And I do not know of any other company. Do tell me if you know of one that is actually committed to what they do being peer reviewed.
Well, that's a question we can ask. We can ask the other speakers in this session.
Absolutely.
Is
you have to tell me
question?
what yes. So
we have a little bit of time if there's a question here in Cambridge or online. So those people who had their hands raised because they're speaking, we've got you now, so you can lower your hand. Is there anyone locally who'd like to ask for the question, or maybe online? Kalin, could you monitor the online? Yep, you could unmute yourself and ask your question, please.
Me?
Yeah.
Yeah, okay. Hi. Regarding sort of category theory in functional programming, I think I once heard category theory described somewhat, I think, kind of pejoratively as design patterns for functional programming. And I saw that and I was kind of like, well, yeah. Because I mean, obviously, so category theory in sort of the wider context, even of computer science, has a lot more varied use. But then in terms of how it manifests in functional programming, I kind of, at least the way I kind of think of it, it seems to be about kind of identifying sort of shapes that things come in that crop up over and over again. And it also has this really robust mathematical theory around it that you can do all kinds of neat stuff with. So I was curious, as someone very integral in bringing some of that kind of with monads and stuff like that into the functional programming scene, what your perspective might be on that kind of idea.
So if the question is it pejorative to say that category theory is design patterns for functional programming, then I would say no, that'd be great. Yeah. Design patterns have been extremely successful.
Yeah.
I think a key difference is that design patterns are a bit hand-wavy, right? You've got certain criteria for what makes a good design pattern, and they are in practice quite useful. But then in category theory, you will generally have some serious maths behind what you're doing, which definitely backs it up and in my view makes it more useful.
Yes.
Right. The thing that was useful about monads was not just the types, but the fact that you had some laws that came with them.
Right.
You could use to work out, wait, is this a sensible monad?
Okay, thanks very much. I think we'd like to move on to the next speaker. Kalin, could you unmute everyone? And we'll thank Phil very much for giving us his time. Okay, fantastic. So next up is Bob Coecke, formerly of the University of Oxford, now of Cambridge Quantum Computing, who needs a little introduction to most people here. Bob, over to you.
Thanks, Jamie. So let me share my screen. Share my screen. Okay, on this one. Oh, there we go.
Where are you in the chain, Bob?
What do you mean, which chain?
Where are you in Phil's chain?
Oh, everywhere.
Everywhere.
Okay, right. So this is my screen. And as Jamie said, I'm representing Cambridge Quantum Computing, but then recently there was some sort of a rebranding exercise and they threw away the computing. So now it's Cambridge Quantum. And then, I mean, if you got OCD like me and then you see this weird line on top, you just go weird. Now, ultimately, it's not really a problem because then this, okay, I joined like in January full time. Then, okay, then this thing happened. So we merged with Honeywell Quantum Solutions, which is part of the big company Honeywell. And as a result, we're now the biggest quantum computing in the world. And so initially, we were mostly software oriented, to use computer science lingo. So we were, but then Honeywell, they were mainly building quantum computers themselves, like so yeah, now we've got our own quantum computing factory besides all the software we do. What does that, I mean, people probably are surprised. What does that mean? Like a big quantum computing company? Is this 3 people or 4 people? So we are 340 people at the moment. Since then, 340. We just got 800 million cash injection because of the merge. So this is big money now. We're expected to be multiple billions. It's expected that not too long from now we go on the market, so then we'll know exactly what this all means. I'm not going to hide that our shares have seriously rocketed since that event. So, I mean, I'm going to talk. So, I mean, I'm very new, as many people here know. I'm very new to this private sector thing. So I was a professor at the University of Oxford. I mean, I was 20 years at the University of Oxford, and I think I was full prof for some 10 years. So what we did, mainly Samson Abramsky and myself, is we built out this big group, which was about 50 people there. Now, the reason I bring this up is because lots and lots of people you see in these pictures as members of this quantum group at Oxford actually have moved with me and are there. I can just start randomly pointing. Samson Abramsky is part-time with us, like 20% or something, or 10%, I don't know. Like Arnie here, Kwang Long, I think he's probably attending the conference, is with us. He's with us. Chantal, who spoke in the afternoon, is with us. I'm probably missing. Destiny is with us. Konstantinos is with us. So lots of people actually moved out. Robin is with us. Probably missing somebody, but yeah. Okay, let's go back in time. Who you see here? Here you see Dimitri. Dimitri is now with us. Is doing all, in my personal team, I'll talk about a little bit more, is doing all the development. And then who else do we have? Okay, Will Zhang. Will Zhang is now the head of the quantum team at Goldman Sachs. So Goldman Sachs have also started pure quantum activity, and Will has gone there, is now heading the quantum team there. So okay, I think that's the oldest picture, and why I'm sticking this in here, because you can see a baby Alex Kissinger, which is kind of funny. You see a bit bigger than baby Jamie. And then you see Ross Duncan here, who I'm going to get back to, and you also see Marnouch show up in the remainder of the story a little bit. So why did I make this move from academia to private sector, since we've built this huge group, like 50 people at Oxford, multidisciplinary group, very much category theory oriented, as everybody knows, because I want to make previous research part of the real world and not just keep it in academia. And actually this thing was kind of happening, like we started to see stuff I'll talk about later, showing up in big companies like IBM and also the quantum activity at Google. So yeah, I mean, it made sense to actually jump in that direction ourselves. So at the moment, Cambridge Quantum Computing, I told you there is 340 people, but we have a new team in Oxford, which is the one which, besides my global role, I'm leading. And this is sort of the current state of the Oxford people. And I'm going to single a few ones out to actually try to get a story together. So yeah, we actually have a sabbatical visitor program. And at the moment we have 2 sabbatical visitors. One is Sean Majid, to pay people probably know from quantum group stuff. And another one is Eduardo Miranda, who's actually a composer, and he's now composing music for quantum computers. So that's kind of fun. So, okay, let's talk about our new head of AI. He actually took over only 3 months ago. Well, there was no head of AI before. So that's Steve Clark. Before he was a professor at Oxford, then a professor at Cambridge. And then he became a senior researcher at DeepMind. Another person I want to single out is Ross Duncan, who's the head of software. So the 3 of us, me, Ross, and Steve, are probably the most senior. We are the most senior people at the moment, research-wise at CQC. I should say we got about 200 researchers. So Ross was in Oxford, did a PhD with Samson, then did work with me as a postdoc. He became faculty at Strathclyde. Now he's full-time at CQC since recently. He left sort of 20% at Strathclyde, but meanwhile done that too. And what he's doing mostly is he's building the leading quantum software platform, which is called Ticket. And I think he's pretty well on his way to actually achieve that this is going to be the dominant quantum software platform. So that's what Ross is doing there. Now, why did I single out Ros and Steve? Because now I want to actually go to research content. So this is a paper which a lot of people in the community know. I mean, there's a number of talks which build further on this at this conference and at the previous ACTs. And for example, Sean Tull's long talk this afternoon fits within this program. So this was a compositional model of natural language we came up with. And you see, Steve, maybe people didn't know Steve that well in this community, but he was the father of this work together with Marnouche and I. So he's been, before that, he didn't know any category theory at all. So he actually went to learn category theory to then be able to push this work further. So this is a paper from 2008. Here is another paper, and now you see Ros there. So this is the X calculus, which also a lot of people in the community know. A lot of work, like for example, by Pavel Sobocinski and collaborators and Robin K. Deleu, is very closely connected to all of this ZX calculus stuff. So ZX calculus was sort of a way to break quantum systems into smaller parts, mostly for Frobenius algebra. It came out of the categorical quantum mechanics thing which Samson and I started. But it's now the most visible thing, and it's actually very visible in quantum culture. And people at IBM who are doing most of the outreach, they think that actually not too long from now, this is going to be the way quantum computing is going to be taught. So based on this paper. So now you can slap those. So you got this paper about language, you got this paper about breaking quantum computing in pieces. You can slap the two together. So on the left, we have now a diagram representing how grammar grammar and meaning of words composes to make meanings on sentences. And on the right-hand side, you see a diagram which represents basically a quantum circuit in the X calculus. So you can basically actually turn language into quantum circuits thanks to the shared compositional structure of things. Once you've got that, then you can develop a theory of quantum natural language processing, really. And we didn't just develop like an abstract theory, developed a theory that's actually suitable for quantum computers as they exist now. So then you can go to this paper. And this paper is basically where we actually start to do natural language processes on existing quantum computers. So this is not hypothetical. This is on real machines. This was very small scale. So this was with Konstantinos and Alexis and Giovanni, Alexis Toomey and Giovanni De Felice, people in this community know quite well. And then with Dimitri, who I mentioned before from the pictures, and Anna and Robin, who was also in the picture, and Konstantinos, we scaled things up to what's now called intermediate. I mean, I take Dimitri's word for that, intermediate scale sort of natural language processing. So, I mean, so we're really doing that stuff. It's not sort of a hypothetical stuff. So basically, this is all based on the compositional structure of, on one hand, natural language, as in these papers we put forward, where we combined meaning and grammar, and the compositional structure of quantum mechanics, as in categorical quantum mechanics, like Samson and all that, and then in particular the sort of breakdown of this in little pieces with the ZX calculus. Now, that's not the only role ZX calculus plays. I just picked one paper out here. There's a whole string of papers where
Bob, maybe another 1 or 2 minutes. Is that all right?
Oh, perfect. So that's a paper. This paper, what it says is like you can use the X calculus to do quantum compiler optimization. What does it mean? Quantum computers at the moment are quite small, so you want to make your circuits which you implement as small as possible. And the X calculus is now also the state of the art of doing that. I mean, there's other things people starting to do now with the X calculus, a lot of error correction. There's a bunch of stuff they're doing now. So the X calculus is actually becoming like the tool of the working quantum computer scientists. And so there's lots of papers by lots of people present here on this optimization stuff. Here is a funny thing. Why am I again advertising my book with Alex? Because currently at Cambridge Quantum Computing, there is a company-wide reading group reading our book. So everybody wants to learn quantum computing. Why? Because the CEO is a fan of quantum computing. He's the one who initiated and funded the journal Compositionality, is funding the HOT conferences and the recent prize, which will be announced for HOT. There will be actually, by the way, an ACT prize too. Like John Byers and me, we just need to get our act together. personally, he supported Grothendieck in his later years of his life. I mean, that's something I only learned recently. Is the founder and chair of the Topos Institute, which we'll hear about from Brendan. And he actually has a paper on CX calculus and consciousness, believe this or not, a very recent one, with people from the Oxford-based Topos Institute. So Topos Institute is in our building on the top floor on Oxford. And the thing you see here is a blackboard. It's the coolest blackboard in the world. I designed it. But so there's a space, a bunch of people are there. And that's all I'm going to say. So if you want to follow us, I'm pretty active on Twitter and I tweet a lot, besides from general stuff, also on this CQC stuff. Thank you, Jamie.
Thanks very much, Bob. Questions for Bob? We got time for a question or two. Yeah, question here.
Hi, I just want to ask, how does the sort of research, apart from what you're saying about it being more connected to the real world, how does like day-to-day research compare to being in academia and being in industry? Is it very different, or is it surprisingly similar? Or
it's a very good question. Like, so I was running a group of 50 people. It's much easier to run this place now than I used to, because you don't have to deal with incompetent university management. Which is a huge difference. You cannot believe how much of a difference that is. People actually support you and stuff like that. I think research-wise, I mean, I don't see much difference, to be honest. In my case, I think the difference is very little, because what we are doing is completely based on work that I was doing before. In Ross Duncan's case, it's a little bit more engineer-driven. It's a little bit more engineer-driven because they actually want to make the best piece of quantum software platform in the world. But still, there's like one of the things which is important there is that at the core of the software in the optimization, it's also compositional stuff like the X calculus and all that. So lots of people there are still doing related things like that.
okay, thank you.
Thanks. Maybe one more question. If there's a question online, raise your hand. We'll have time for questions at the end. Okay, I think let's thank Bob very much for his contribution. Okay, so next up is Brendan. Brendan, can you unmute yourself? Are you there?
Hey. Yes, I'm here.
Joining us, Brendan works for the Topos Institute. You're probably the chief executive or something very impressive or something like that at the Topos Institute, which Bob just mentioned. Brendan spent a lot of time in academia as well and still does a lot of research at the Topos Institute. So over to you, Brendan.
Great. Thanks, Jamie. Let me share my slides. Great. Yeah, thanks, Jamie, not only for chairing, but I also want to thank you for intentionally taking upon the task of organizing ACT this year as a hybrid conference and under these highly uncertain circumstances. You and your team have done an incredible job, and I'm so pleased we have a space this year for our community to gather.
Thanks.
Rain, shine, or pandemic. So, yeah. This year, I'm really grateful to have the chance to just share some updates on Topos Institute, which, as Jamie mentioned, is a new research institute where I now work. Let me see if I can get the slides changing. So, in fact, last year, this time last year at this conference, ACT, I gave the first ever public presentation about Topos. And since then, in January 2021, we began sort of activities proper. David Spivak, Valeria DePaiva, Evan Patterson, and I moved full-time from our previous positions to work at Topos. And while last year I spoke in particular about this mission, Topos is a new independent nonprofit devoted to shaping technology for public benefit by advancing sciences of connection and integration. This year, I'm really pleased to be able to share a lot of development. So for those who are new to this organization or new to hearing about this organization, I'll share again briefly the goals and the mission and a real reason for creating this. But this year I can also share more about what we're actually doing and have been doing over the past 6 months, and a few words on how you can get involved too. So first, just a high level picture of the Institute. And it begins with quite a hopeful statement, I think, and a hopeful statement that I think is at the core of this community, which is a belief that new math sometimes changes the world. So one of the oldest examples I can think of is this shift from the Roman numerals to a positional Hindu-Arabic number system. And while this is almost just a notational change, it's a notational change motivated by a deep structural understanding of the natural numbers. And I think it's no exaggeration to say without it, we couldn't consider, for example, doing things like calculus and differential geometry and many other things technologically we do today, such as space travel. And we see there's sort of a new space race going on this year. So something perhaps closer to the foundation of this community is what Bob just talked about, which is categorical quantum mechanics, which shows up now 15, almost 20 years ago, reframing quantum mechanics through this categorical string diagrammatic structural lens. And Bob's just talked about some very exciting work to do with combining this, this understanding with an understanding of natural structures of thought and language to produce quantum natural language processing. So again, new structures leading to new technologies. And in fact, this is really, I think, a strong part of this community as we are the applied category theory community. So we take this beautiful, powerful structural mathematics category theory, but there's this central belief that it can reflect the structures involved in applications in our daily lives, and that understanding this is a fruitful scientific pursuit. But if we're to take the statement seriously that new math sometimes changes the world, I think a question that comes along with it is, how do we want the world to change? And what is our role and responsibility as mathematicians, as computer scientists here? And while we believe at Topos that category theory in particular and related subjects provide this science of connection and integration that's mentioned in the mission statement, it's also the case that we're building as a society, as a sort of global planet, technologies of interconnection, and it's not clear that everything's going according to plan. So we have these global systems of trade, we have the internet and social media, and these are built with the aims of enriching humanity. But we've seen, even right now, this pandemic that prevents me from speaking to you in person, climate change that has made this year in California, where the headquarters of Topos is based, a year, sort of a very dry, very hot year. We see disinformation and questions over the effect of social media on democracy and governance. And so part of the question we want to ask too is can we do better? Can we make these systems safer? Can we make them more sustainable? Can we shape them to ensure human flourishing? And again, because category theory speaks to, at its core, ideas of relationship, of communication and cooperation, we believe that there's something we can contribute to this problem. We certainly can't solve, and we certainly not sole change makers in the world, but we can play a role in a more, in building safer, sustainable, ethical systems. And so this brings me back to the mission statement, which again is that we're an organization devoted to shaping technology for public benefit by advancing sciences of connection and integration. So what does this mean in practice, and what are we doing today? First, it's important that we stay at the forefront of sort of category theory, of type theory programming languages and its applications. And so we've got a core research program which seeks to move across this chain that Phil Wadler spoke about, from sort of the theoretical production of mathematics and structures to building software and applications and making it accessible to the public. And so this sort of chain roughly runs from left to right in these three initial research themes that were picked out, where on the left, we're talking about sort of work on the theory of polynomial functors or or sort of the optics, compositional cybernetics. A lot of the stuff we've talked about, we've seen at this conference so far, and we'll see throughout the week. Asking questions like, what are the right abstractions for distributed decision-making, distributed intelligence? In this middle column, it's about how we structure and compute with scientific models, and more focused on the production of the actual computation, the production of software. So we have this, we contribute strongly to this algebraic Julia open source project, which, for example, you see at the bottom of the middle column, a Petri net that's been constructed through category theoretic compositional means through colimits and cospans. But it's executable, and so it can be passed to, say, a differential equation solver to produce these pandemic modeling curves. And then on the right-hand side, we have a project around the sharing and navigation, sort of mathematical collaboration, how we organize our knowledge. And the project here is to indeed take ideas from category theory as a sort of central, in its central role as structuring mathematics, but also bring in sort of modern AI, natural language processing tools to provide, for example, better search tools for the in-lab, or provide ways to navigate similarity across concepts, which we hope will speed up concept and paper discovery, enhance collaboration between us, and also make the field much more accessible, both to, say, programmers interested in implementing categorical structures, but also the wider public who might be interested in learning category theory for various purposes. So that's the core scientific side of what we're doing at the moment. But Topos is about science and society. And so equally important is our sort of public engagement, community building efforts. And so, for example, we have a very active YouTube channel where we're helping to support the NLab as it migrates to new servers and improves. We support various teaching and mentoring projects like the Adjoint School, and a seminar that we're running led by Eugenia Chen called the Emerging Categories, Emerging Researchers in Category Theory, so MCAT virtual seminar. And as we move forward, we're interested in expanding our research to looking at concepts like technology and society in ways that relate to our core expertise. We're thinking about sort of the ethical implications and ways to anticipate impacts. And this will inform our work around sort of public dialogue and policy around emerging technologies. So in particular, we think that as a community, we're contributing to sort of systems and communications infrastructure of the people. We do want to ensure that the public has a voice and understanding in what's going on, so that the infrastructure we create does belong to the public. So next, who's involved? Just quickly, where I'm very grateful to have the support of people and mentors of mine across this community. So here's a quick slide of who's involved, and I'm sure you'll recognize many names. And then not only internally to the organization, but we have it's a sort of wide social project, and we have a bunch of support external across society, from individual and foundation philanthropy to government organizations to industry organizations like CQC or CQ. I've got the old logo in the bottom left on the slide here. So both internally and externally, it's a growing community. And one question we get a lot is how can people get involved? And we've felt a lot of support from this applied category theory community in particular, which we're really grateful for. So I want to close with just 4 quick ideas or ways that people can get more involved with what we're doing. And the first is simply to be part of the community, to join in our events, either in person or online. So if any of you are based in the San Francisco Bay Area, or if you're ever passing through, we held a seminar at our Berkeley office on Tuesdays at 4:30 p.m. All are welcome. We go out for dinner afterwards. We'd love to see you. For those participating remotely, we run a variety of online events. So for example, every Thursday at about this time, we run our colloquium, and I'm sure you'll recognize many of the upcoming speakers. So this colloquium's over Zoom and YouTube. And on Thursday, which you can also attend in person, but we expect but it may be easier to attend online, we have a 13 lecture course on polynomial functors. So we have a variety of sort of workshops and courses coming up around various aspects of our work. And for asynchronous communication, we've launched a blog in the last couple of weeks. We hope that it'll become a lively sort of place online for discussions about sciences of connection integration, about category theory, and about shaping technology for public benefit.
Thanks very much, Brendan.
Oh, sorry. A few quick more slides. Sorry, Jamie.
Maybe one more minute.
One more minute, I can fit. Yeah, sure. Another project is to get involved with this Algebraic Julia project. Again, it's about open source software for scientific computing based on applied category theory. You can go to these websites, algebraicjulia.org. It's a great place to start to look at open source contributions. One thing I want to mention just quickly is another way you can get involved is to share your knowledge. So we're talking about organizing mathematics with natural language processing. For this, we need new data sets so we can provide these tools for annotating, exploring mathematics. And for this, we need to know how expert category theorists yourselves see mathematical or category theory text. So if you have 5 minutes between a talk, for example, during this conference, please check out our blog and annotate some TAC abstracts for us. And finally, this fourth way you can get involved is just to spread the word. We're a growing community. We're interested in collaborators of all sorts, scientific, but also across industry, government, philanthropy. So please let them know about us or let us know about them. We have these two websites, which you see at the bottom, one to learn about the vision of the organization, team and opportunities, and even donate if you can, and the other where you can engage more directly with the scientific work, where you'll see the blog and announcements about our events and talks. So thank you. And here's my email if you ever want to get in touch.
Thanks very much, Brendan. Do we have any questions for Brendan here in Oxford or online? Yeah, over there.
Hi. So I guess there is lots of research topics that could fit your mission statement.
Mm-hmm.
I'm wondering who chooses what specifically you research and how do you choose it?
It's a great question. So far, we've been very much shaped by the personnel involved and sort of how we feel we can best contribute from where we are, especially, and where sort of possible funding streams will come from in the near term. But in particular, in the next couple of months, we're undergoing a strategic planning process, bringing in, sort of consulting widely across this community and others to just figure out, I mean, as you say, it's a broad mission and we want to find somewhere where we can make a meaningful impact. So we have a board of directors led by, for example, Ilias, the CEO of Cambridge Quantum, but also Ed Cometa, a major functional programmer, a major contributor to Haskell. And we'll be growing this board of directors. They'll help decide the strategic mission. We have our faculty that thinks about what we can execute. And we'll be creating a board of scientific advisors too. John and Eugenia are already playing this role, John Byers and Eugenia Cheng. So it'll be a community effort.
Thank you.
Thanks very much. Okay, I think we should move on. Dan Geeker, are you here? Maybe raise your hand if you're here. He's not here. Okay, he might be able to, he said he might be late. So let's move on to Jelle Herold. Jelle, are you there?
Yeah, I'm here.
Great. Hi, Jelle. We can't see you. Is that all right? Maybe that's by design. There you are. Great. So it's my pleasure to introduce Jelle, who I've known for a long time. Works at Statebox, a number of other people in our community, and we're looking forward to hearing from you today. I think you have a video you want to show us, right? We're ready for anything. Brendan, maybe you could unshare your screen.
I'm gonna try to share the screen.
Yeah.
Between this.
Yeah, so over to you, Jelle.
So yeah, thank you, Jamie, for the invitation to speak here. Jamie asked me if I could say something about category theory and its application in industry. And I guess since we're industry, I'm going to tell you about what we're implementing. We have these two projects, Statebox.org and Process.io, and we put it like this. So Statebox is leading the shift towards structural computing based on category theory. Very humble. And Process.io is a cracked by construction process management platform built on Statebox. So I will make you a little bit more clear what this is exactly. But by structural computing, we mean this idea that was put forward by Spencer Breener so nicely with this diagram. It tells you that if you follow the blue curve, you end up in this sort of area of very complex but dense applications that you can actually build because they are very, very structured. So we started calling it like structural computing. When you apply it to computing and to systems, and let's say cybernetics, it's all in the same realm. And we do this by using the diagrammatic aspect to make things clearer for various stakeholders in processes and so on, but also by going mathematically to the reality and not sort of with handwork and doing it manually. So we want these things to match up. So I'm just going to play this demo to you, which will show you how it works, and it's 3 minutes. I apologize if the sound is a bit soft.
This is a demo of Process.io. What you see on the left is input text, and on the right, the output. You can type in Markdown text, and you can see the render. What you see on the left is input text. The platform is collaborative.
We're getting a bit of feedback. Is this on YouTube? Should we play it locally? Would that be a better idea, do you think? It's not playing very as smoothly as I was hoping, Jelle.
Of diagrams.
I'm trying to quit it. My computer is currently.
We can sort of hear the audio. Could you put the link into the Zoom chat?
Yeah, one moment. I have a very slow netbook. I'm sorry. It's
okay.
The Zoom chat. And a small screen. Oh my God. Where's the Zoom chat? Help.
If you unshare your screen, you'll be able to find it.
Oh, yes. There we go. Thank you.
Thanks. Alex, can you bring that up on the? You maybe just play it on that second screen. Maybe restart it. That's a good point. Well, maybe everyone, will that work? Okay, all right. If not, people can use the link and they can view it locally. Yeah, so let's just try that. Okay. Maybe turn the audio on. I think the audio is muted. Volume up.
You know what? This is a bit hard to hear on Zoom. I don't know if I'm the only one. terrible. If I talk, you hear it. I think that's very confusing.
So so Jelle, here in the lecture hall, we can see it fine. Maybe people can follow along on their own.
We can actually break it up as well and then just continue with the slides, so don't spend too much time on it. I think people have seen the platform and then I can explain a bit.
Well, there's only 1 more minute. It's quite good. Can we just watch the end?
Sure.
Let's have a look at the box. When the candidate is hired, 2 tokens are placed. Each of the 2 actions can take place independently. The employee, however, can select his first day unless all items have been provided. Combining the hiring process with the onboarding process gives us a complete overview of the HR protocol. To summarize, the candidates are placed for the job, get an invitation, passes the interview, that is confirmed for the other departments to prepare what is necessary, and the employee can start the first day.
Okay, so we finished the video. That came through very nicely here locally. So thanks that demo worked fine. Do you want to keep going, Jelle?
Yeah. Yeah, sorry for that technicality thing. Because on Zoom, it was a bit hard to hear the audio. I kind of saw this coming. Do you see my screen again?
Yeah.
And over here, you see this picture as well, right?
Yeah.
Yeah. So this is the same idea as what you've just seen, but in a more complex way, where you have multiple pages, and on each page, different things can be defined, and they will be linking across pages. And you see that this forms some sort of operated structure where you have nested protocols and so on. So I mean, return to the slides. What you see happening is that we use a categorical way to specify a process, namely give the generators of a category. And that's the category of its states or the state space, and that's given by free construction. But actually, you might also want to attach some semantics. So you have another functor to another symmetric monoidal category where the boxes suddenly actually do something. And to go on, there's all these different kinds of categories. Maybe you need a colored patronet for a multi-party protocol. And then all this stuff starts fitting together into all these different interactions between them. And this is a lot to program out. You're tapping into these different fields. And how do you structure such a program, especially if it needs to be very precise? And that's what I think the application of category theory is sort of in the industry. It's to do this sort of merging of domains and give a universal or shared language for it. And for us, we can already see it at a very low level. We have this static concepts, classical logic, let's say stateless stuff, timelessness in sort of syntax or in patronet, and dynamic, linear, stateful, time-like stuff in the semantics. And we would like to separate these in our programs. And if you can, that saves you a lot of So we are currently using a cryptographic peer-to-peer protocol. It's one-time verifiable encrypted signatures, where we combine essentially protocols, game theory, and topology, or you would need to combine those to be able to fully specify such a protocol. And we think of that as a minimum viable prototype of such or product of combining three fields categorically, let's say. And so the platform you see is a platform where you have, it's really a literate platform. You can think of this as something like ShareLaTeX or GitHub or whatever, HackMD, where you can share documents and descriptions of processes, but more generally of morphisms in monoidal categories, and later add semantics or labels to this. We keep the categorical stuff hidden, like Wadler said. We can't tell our users about monads because they get scared. And it also has to be collaborative because you want to work with multiple people. So it's collaborative in the sense of diagrams make things clearer, and hidden category theory is the thing that enables different domains to talk to each other. And lastly, it has to be under a free software license. So yeah, that's what I had to say. PS, we're currently right now closing an investment round. So if anybody is eager to join this, you can contact us. And we also soon will be hiring. So if you're very interested, also feel free to send an email to this address. And that's our Twitter handle.
Thanks very much, Jelle, for that fantastic presentation. So are there any questions? Please raise your hand online if you have a question, or in the lecture theatre. Yeah.
You said something about Libre licensing, and free software. Which license? Just wondering.
Yeah, we're thinking of a mixture of Mozilla public license and AGPL, GPL code.
Okay, cool.
It's interesting that this question of hiding category theory comes up so frequently. Shouldn't we draw something from that? I mean, if we're saying we have to hide category theory to do category theory, maybe we don't know what category theory really is. What do you think about that, Jelle?
Well, that's a deep question. Yeah, I think in a way we're kind of doing naked category theory because we're not really hiding it. We're just directly exposing a morphism to a user. We're just not calling it a morphism in a monoidal category. I mean, it's saying it to you guys, but I certainly don't tell it to customers in order to explain it, let's say.
Okay, any more questions for Jelle? Okay, so let's thank Jelle again for a really fantastic presentation. Thanks very much. Okay, so Ryan Wisnesky, are you there?
I'm here. Let me share my screen.
Good to see you. You don't seem to be moving. Is that a static image or a?
Fooled you a bit, did it? Yeah, it's a static image.
Oh, that's fine. As long as it's doing what we're supposed to be doing. Okay, so I'm delighted to have Ryan as our next speaker. Ryan works at Conexus, which is a database, categorically inspired database company that David Spivak, who chaired the session, is also involved in. They're one of the first companies in this sort of modern era to be directly trying to use categorical ideas to build their product in a very explicit way. So over to you, Ryan.
Thanks. And yeah, when you pinged me, I was actually writing a reply into the channel that, at least from our perspective as commercializers, hiding category theory from a user is kind of like hiding metallurgy from the buyer of a car, or like the theory of flight from people who are riding in airplanes. That there's a definite shift in perspective between like people who pay money for software as users and then our interests as researchers. But anyway, thanks for the introduction. Hopefully everyone can see my slides. And as you said, I'm here representing a spin out of MIT. So David Spivak is one of the other co-founders, and we are commercializing his work straight up the middle. And so we've landed in a data area, like we do data warehousing, data migration, extract, transform, load, that type of stuff. However, since I think most of the people here are actually category theory researchers, what I wanted to do in this talk was actually summarize what our software and papers can do for researchers as opposed to folks manipulating data in practice. That being said, if anybody here has a commercial problem related to data management, we'd love to talk to you. Anyway, so I'll carry on here. So what I've done is, oh, and also I should mention, like you can go to categoricaldata.net or conexus.com. I'm going to show screenshots of software and cite papers, and they're all linked to from there. So what I've done in this talk is just put together a few areas in which what our software can do, and then just was going to run through them real quick. So the first core competency is working with finitely presented categories. So we've seen a lot of categories in this session from Statebox, other folks. And so what we think about at Conexus is not categories in general, but the finitely presented ones. So these are ones that are given by generators and relations. And so we built a lot of software that lets people define finitely presented categories, solve their word problems. That means construct a decision procedure for when two errors are considered equal, and then do all kinds of other stuff with them. So here's an example of the tool in action. So when we say schema, a category theorist would say category, but what you can see in this picture is the Cayley graph of essentially a group that has been written as a finitely presented category over one object and two generators. So over here in this text, you see a presentation of the dihedral group of order 2, one object G, two generating arrows R and S, and then some equations here. And then in this image, you can see the actual Cayley graph that's found 4 elements. So I guess the order 2 thing means it has 4 elements. And then it's actually constructed, the Cayley graph. I won't get into what that is, but it's like a construction from group theory. So anyway, that's, if you're dealing with finitely presented categories and you need to do calculations on them, then I would encourage you to check out this CQL tool that lets you do stuff like this. Similarly, if you're interested in working with what are called co-presheaves, and so, algebraic Julia has some of this. The idea is basically if you have, a category, then you can have a set valued functor on that category, and that's what a co-presheaf is. And so our technology is very good at defining and reasoning about finitely presented co-presheaves with attributes. And so, one of the often overlooked intricacies of doing data management with category theory is the fact that category theory is purely structural, whereas a lot of data is material, right? Like the set Alice, Bob, Sue is not just a bag of 3 dots from a data perspective. It matters that it's Alice and Bob and Sue. And so we had to use category theory to extend the theory of co-presheaves with something called attributes. Anyway, you can do all sorts of cool stuff with these. You can take SQL databases and turn them into co-presheaves and export from our tool into co-presheaves. We've built all kinds of converters for different data models. Let me show you what these things look like. So what you start with is a finitely presented category like I was mentioning earlier. So in this case, our finitely presented category has 2 objects, employees and departments. It has some generating arrows, manager works in, and secretary, saying, for example, that employees work in departments and secretaries go from departments to employees. There's some generating equations. Every secretary works in the department that they're the secretary for. And then some attributes, which are basically just morphisms. But what you can see here is data on this co-presheaf, and it's written in a tabular form. And it says what you might expect, like, oh, this set valued functor has math and CS departments and Al, Bob, and Carl in it, and it's missing some data. It's missing the last names for Al and Carl in particular. And so anyway, we have a full-fledged data manipulation tool based on the theory of co-presheafs. And moreover, based on the theory of functorial data migration. And so those of you who are familiar with David Spivak's work, might recognize this idea that you can move a co-presheaf from one category to another using a series of adjoint functors. So you have a functor from C to D and a functor from D to set, you can compose and get a functor from C to set that forms one of the operations of functorial data migration. And then that operation has two adjoints, usually called sigma and pi. They have semantics that's useful for data related things, as well as other parts of category theory. Bit tricky to compute though. So, I have a bunch of papers about how to do that, especially how to do that at scale. So often doing something on a toy example for a paper is different than doing it on terabytes of data running on a cluster. Anyway, final thing to mention there is that an interesting research result actually is that pairs of functors can be abbreviated into something called a profunctor, which has a very SQL-ish notation. And so when we work with customers, we tend to use stuff that looks like SQL as opposed to category theory. Anyway, as an example of what that looks like, here is one way to, or this is an example of functorial data migration. You're starting with faculties and students, and some TAs are faculty and some TAs are students in this case, and we're trying to compute all the people without double counting who's considered a TA. And so we have a functor from this span category to this commutative square category. And if we start with this Copri sheaf here that has Alice, Bob, Ed, Finn, and Gil, then you can complete the person part of it in a way without double counting. So that's just an example of a kind of data migration thing that you can do. And then finally, I guess the final thing, or next to final thing I wanted to mention is that for researchers who are doing category theory that's not combinatorial, which is to say, you have infinite sets, there's a bunch of automated theorem provers that are underlying our work. And so it has both open source and proprietary ones. We sell the proprietary ones that work well at scale. But anyway, you can use the tool to do not just computational category theory, but because categories are, algebraic objects, you can do things like group theory because you can write a group this way. And so here's just an example where we've written a group as a product category. So, it has, in this case, we call it a type S. It has an empty element. It has an identity function, a compose, and then some axioms for group theory. You can actually ask our tool a universally quantified question. And so it's asking, in this case, do you get right cancellation of your identity elements? Can you prove that from the left cancellation? The answer is you can. And so, yeah, we have a lot of stuff like this that we hope can be useful to other researchers. Finally, on that note, just wanted to announce, as a startup, we try not to do research, we try to commercialize, but we are doing some research along with our friends over at Uber, and Josh Myers has been leading that up. He's a member of this community, not sure if he's here at this conference or not, but anyway, there's a volunteer project going on this summer to liberate a Haskell version of some software from Uber and get it into an open source, the Apache Tinkerpop Graph Foundation. And so that's related to a lot of the work that I was talking here in like a generalization sort of sense. How can you generalize the notion of schema to be more useful even in practice? So, okay, that's about 10 minutes, so I'd better stop there. That was a lot of content, but I'd encourage people to reach out to me if they're interested in collaborating or just interested in what they saw, at all. All of our papers and the open source software that you've seen are at categoricaldata.net. There's always conexus.com for people looking to do data migration. And yep, please drop me a line. Would love to talk to you. And thanks for having me. And hope the rest of the conference is just as good as today was. Thanks.
Thanks very much, Ryan, for that fantastic presentation. Are there any questions for Ryan online or here in the room? Oh, hi, Dan. You have a question for us? Dan, you're unmuted. I think Dan doesn't realize he's unmuted. Maybe we could mute Dan. Interesting versus combinatorial. Could you say a bit more about that?
Sure. So there's a book, for example, Computational Category Theory, that does a lot of finite category theory in a very elegant way in the OCaml language. And there's also shallow embeddings of category theory in the languages like Haskell, but here what I mean by interesting is defined by generators and relations. That, at least from our point of view in data management, it's the presentation of a category that's actually the interesting object of study. That's the database schema, not the actual category itself, which is kind of like a abstraction across a lot of different things. And so, yeah, at least for us being so concrete, we see a lot more of the presentations in the wild as opposed to actual categories.
I see. So you're interested in the free Cartesian category on the presentation, or just the free category?
They're never free. Sometimes we see them, but
free modulo
group.
Sure, presented, right. but is it a category presented or a category with structure presented with this?
Good question. The answer is both. They require different techniques to handle, and so for example, in this work we're doing with Uber, here we're thinking about categories with products and co-products straight up and building automated peer improvers that work with them directly. And some of the other work, we just consider products, or we'd consider none of them, or we consider each case independently because you have to build different provers to go fast for each different case.
Okay, thanks. So we have a question online from Hans. Sure. Would you like to unmute yourself, ask a question?
Oh, hello. Can you explain some of the work on the pre-Coecke and like are you able to compute certain limits of these, or like what is the aim of your software in that department?
Sure. So the real aim is to implement functorial data migration, which is a way to move co-presheaves from one schema to another in an adjoint type of way. That's the basis of it. However, the tool itself can do a lot more than that. It can compute co-limits of co-presheaves. There's operations in there for solving, I guess you'd call them lifting problems of co-presheaves. There's a whole bunch of different constructions that you have that we just had to add in order to be able to use this technology for data management purposes. There's about 100 different constructions in it at this point. Other questions?
So is this tool your product that you sell, or is this what's the business model with respect to this tool?
Right. So as Jelle was mentioning, it's few and far between the kind of people who can sit down at a tool, enter the group axioms and then, make progress in like some enterprise. And so what we've been selling, and I didn't really talk about in this talk at all, are ways to wrap this product to make all of the category theory disappear. So for example, if you're interested in building a data warehouse, we have a UI that will hold your hand through the process of like forming a co-limit, drawing a diagram, generating a CQL program to execute it. And then, so the commercialization has all been trying to get this stuff into the hands of people that may not know either category theory or database theory.
Right.
So many programmers are just, not even computer scientists, for example.
Right. Okay, thanks. That's super interesting. So let's thank Ryan again for his great presentation. Okay, and that means at the top of the bill, we have Dan Geeker from Huawei Research Labs. He just left. We had him and he left. What an anticlimax. Okay, well then let's have a discussion in that case. If Dan comes back, maybe you can look out for him. A topic that there are several topics that came up in many of the different presentations. I like this question: to publish or not to publish. I thought I could throw that one to you, Bob. So, what's the point of publishing in industry?
We publish everything. We just publish like normal, no different.
But why? What benefit do you get from it?
Show who you are, show what you can do. You can always protect your stuff if you want to. Before.
So is that typically respected? If you go, I don't know, you're looking for a round of investment and you say, look at our research papers. I would have thought maybe could even be the opposite, right? That we want that investors would say we want technology that's real and that works, not technology that's written down in research papers.
Yeah, but your papers can be about stuff that works. Huh? You've done experiment, you show you can do something, and then you write a paper. There have been recent cases of that a patent is first applied for, and then you have to wait a few months to publicize. Well, one of the things is like, if you put a paper out, it's not that you just stuff it on the archive. There's like a PR machine behind it, which wants to make a lot of fuss about it. I mean, depending on what it is, of course. But yeah, I mean, if you look like when Google did their supremacy experiment, they published this, of course. They want to get as much as possible media.
How about, was there a question here? Yeah, go Nick.
Let me just. Cool. So I heard from all the industry speakers, and a common theme seemed to be this idea that you really need to hide the category theory from the consumers or whomever you're selling your product to. I just wanted to hear if anybody had any experiences of doing the complete opposite and going like full abstract nonsense and seeing how that worked. It would be nice to hear about.
Well, that's what we've done. Full on.
Is it though?
Yeah, I think so. In AI, there is now more and more sort of people, big names starting to say, hey, category theory, there may actually be something. They actually don't even know what it is. So at that point, it becomes a good thing.
So you can kind of just bamboozle them into giving you money.
Well, no, but it's not a bad word. And I mean, in quantum, it's completely changing now with the X calculus. That is now a completely common accepted thing. So before, I completely agree. Like before we had this choice, either you submit your papers to LIX and it has to be category theory or it doesn't get accepted, but then the physicists don't care at all. Or you want the physicists to care and then you get rejected from LIX.
I'm also curious about this name, like Topos Institute. So I'm not sure if they're like a corporate, like a company that has a product that they're trying to sell, but I wonder if the name Topos maybe scares people off, or you have to go around explaining what a Topos is, and that might, is that a pro or a con?
Well, it's not, Brendan, are you there with us still, Brendan?
I mean, most people don't know what a topos is, and that's fine. It's a 5-letter word, 2 syllables. It's friendly sounding.
Do you ignore it, or do you tell them this? So first you start with like a site, and then
no, we don't. We say that a topos is a place where you can do mathematics, and it's a nice word, but it functions differently as just a brand and as a name for our organization.
Jamie, if it's possible, I would just like
yes, please, Fab, go ahead.
Yeah, so I also basically work with Statebox, and on the idea of publishing paper, if it's that important or not, I think it is not important to sell the vision of what you're doing. When you talk with a potential investor, usually they are interested in the concepts of what you want to do and how they may or not be profitable. But usually a sensible investor, before giving you money, will do their due diligence. And in that case, they may look the papers themselves if they have the capacity to, or have a technical team that, will just go through what you publish to say, to check if it's sound or total BS, basically. And about hiding category theory, I think that a nice comparison would be with the early radios. Like early radios were basically, a revolutionary application of electromagnetism and early electronics. And it's not like you hide it. You say these are new revolutions in engineering that we are using. But what an investor may care about is, do I have to know electromagnetism to operate a radio? So that is the point. The point is, we actually do want to make the words category theory very trendy in the investor landscape. That would work great for everyone. But to do so, you have to ensure that the final user may use your products without getting a degree in category theory. And I think that's the kind of game that you have to play.
Mm-hmm. Yeah, thanks. I think you've made that point very nicely. Jelle, did you want to make a comment?
Yeah, I guess on the hiding, I think it's maybe we're actually not hiding it. We're kind of exposing it. I think the problem is often that the category theory is either hidden or not there. There's just something slightly different. It's not exactly a box and wiring diagram. It's or with some sort of super weird semantics. So with us, you really type in morphisms. It's not even a Petrinet. It's really a morphism in a way. So arguably, you're not even hiding it. You're just making it more simple and more presentable. Yeah.
So Brendan, you gave the example in your talk of Arabic numerals as an innovation over technological innovation over Roman numerals, right? I think I read that at a certain point in a certain harbor trading area in the ancient world, Arabic numerals were banned because they were seen as giving an unfair competitive advantage to a certain class of traders who'd been trained in this secret technique. And I imagining groups of secret police going around breaking into warehouses and checking clay tablets for these clandestine Arabic numerals. Maybe it could go that way with Conexus. Maybe, I don't know, we'd be a victim of our own success in that case. Does anyone else, someone else has their hand raised? Yeah, go for it, Nick.
Hi, yeah, I just have a comment about this hiding of category theory. And what I want to say is, many people are using category theory whether they know it or not. And often these coherence rules and stuff really looks like complex. It often really tells you how you can put together some things or how you can't. So sometimes I feel like hiding this thing, sure, the word sounds scary and you have to work on educating and sort of making it intuitive, but they really talk about some things that are quite useful in programming and in building the system. So somehow it's more of a comment that hiding is sort of it gives off the bad impression that there is something to hide, where in fact this is just elaborating the things we were just doing all along in a coherent way. So I think that's something to have in mind maybe when building the system.
Yeah, thank you. Did you want a response from someone in particular, or?
Well, it's more of a comment than a question. I guess I'm that guy.
Okay, so there's someone online has their hand raised. Eswaran?
For me, as an engineer who's working with category theories, why it becomes important is both from what Ryan talked about, moving of data from different places, from different tools and different perspectives, and then creating certain views into them. Those all become very important. In fact, I would argue that engineers have used diagrams and mathematics in this fashion for a very long time. What category theory does, in my mind, it makes it transparent and formal, thereby allowing you to do a variety of things and even to project to the different engineers the different views of the world they want to participate in. And this, believe me, practicing engineers understand extremely well. It's just that we need to figure out how to articulate how category theory plays a role in the way they manage their knowledge during the design and the data and the tools. That is the key to get to them. And they know the problem. That is my comment.
Thanks.
I can comment on that. I can give a comment on that. That I also feel that in industry and practical worlds like engineers, people are a lot less dogmatic than in academic world. In academic world, you need to play these games like hiding category theory against certain mathematics because they hide it and stuff like that. Outside of academia, these dogmas, they're gone. Because a dogma is going to cost you, whatever it is.
I totally agree with you, Bob.
Same here, very expensive.
Yeah, hi. I guess on the topic of not being dogmatic, when is category theory going to be powerful enough to be dangerous? I mean, asking for a friend, but how do I do evil category theory? Like evil category
Well,
theory?
that's a good question. And in fact, last year we had a bit of a point of contention with some sponsors of the conference who were deemed to be not BAE Systems, for example, and Honeywell have previously been well, Honeywell now own Cambridge Quantum Computing, right? I think they've done some have they done arms manufacturing in the past? I'm not sure. The point is we're already having these ethical discussions as part of the community quite regularly. Do you have some idea how we can handle that? How can we avoid these ethical problems? Or
you're asking me?
Yeah.
No, I'm not asking how to avoid them. I'm asking how to do those things. I'm asking the opposite. I'm asking how to do those things.
Yep. Ping us.
Would our panel like to come in on that?
As long as it's profitable, we'll help you.
Ryan, seriously, if you were, would you be happy to work for, I don't know, BAE Systems or Topos Institute? I mean, that's not an issue for you?
I suppose it's more that working in data integration, we're already exposed to these ethical issues. And so, for us, it's the same old thing, like patient privacy or, as opposed, so it's not new to us. So I think maybe we're more comfortable with it than some, but that's just because we're in data.
Yeah, I'll comment that I think we're building tools, and I think we're building powerful tools, and the tools for data integration, they're tools for coordinating large groups of people to do various things, whether it's, one grant received recently in the US, not by us, was around using categorical methods to think about search and rescue. And there's a thin line, arguably not much line, between search and rescue and search and destroy. And I think it's important that we think about, who has access to our ideas and the values that are used to deploy them. So when you ask sort of, how can category theory be used to for evil purposes? I think Jamie's very right when he says it's already there. It's already possibly in our work, and we need to think about what our role is in that.
Thanks, Brendan. So maybe as the last thing we could think about, so we're at 5:30 here in Cambridge, but I think we can go a bit longer because we're having a nice debate. Something I wanted to raise is, how good are we as a community, right? Which is fundamentally a pure mathematics / computer science / physics, unusual sort of academic community. How good are we at reaching out to industry, generating these sorts of spin-offs? Maybe we're great at it. Maybe we're already doing it as well as we can. Maybe we're terrible at it. Maybe there's all sorts of things that we could be doing. Maybe we could be doing more, but we shouldn't, because academia is its own thing, and academia doesn't need to orient itself towards industry. I wonder what the panel members think about that. Stony silence. What about you, Bob? That's something you've thought about a lot.
I never expected to be in the situation where I'm now. It just went very quickly. I never even considered this as possible or something like that. And then it happens. It's a different, yeah. I don't know. David is also on this side.
Yeah, David, you haven't.
It's easier than you think. It's in a way easier than you think.
So David, you haven't. Are you with us, David Spivak?
I am. Yeah.
Yeah. Maybe you want to come in on that point.
What was your question, Jamie? How hard is it to move into industry, or what?
Well, so the question is, what could we be doing as an academic community to be encouraging to these sorts of industrial connections? Maybe we're already great at doing that. Maybe we're terrible at it.
Well, if you're interested in your stuff landing into the world somehow, then I guess you hang out with people who you think can help. And you try to explain it in words they understand so that they can explain it back to you and say, that they get it. And then often people are quite interested to make something and to get their hands dirty. And so that's great. In terms of I would try to interact with people who I like and who seem like they want to do good things for the world. So I think one thing we can do regarding the question of morality is yes, any tool can be used for good or evil, but if we have a garden and we plant lots of good plants in it, then they will be flourishing before the bad plants, quote unquote. And I don't have a good theory of what good and bad is, so I don't have quite a good ethical theory that like explains it all and makes a good sharp line distinction, but just in terms of following our own kind of moral conscience and hanging out with the people that we enjoy hanging out with and feel good in that kind of way. So I think it's just a matter of like good communication with people that are that feel aligned.
Yeah, we got a question up here.
Yeah, I'm trying to think of how to phrase this. I guess category theory is complicated enough to explain and to understand, I guess, at the level that you guys actually want people outside of the field to understand it. Do you think that it's important or even possible to get people outside of the field to actually get it at the level that you want them to get it? Or do you have to like maybe spend a lot more time developing tools that perhaps skip out on some of the math, but maybe deliver an idea to people of what it actually is, you know, enough to some extent? Like what, basically, I don't really know how to express this thought, but I guess it's important to communicate what these ideas are and what this way of thinking is. Do you think it's actually possible, and to what extent is it possible? Maybe. Yes.
Would anybody like to answer that from the panel?
I'll take a shot. I think it's very possible. I think we could be doing a much better job. And I think in all this discussion, when we talk about what it means to hide category theory or not, I think there is still a lack of clarity about what category theory actually is at a practical level. There's sort of a syntactic understanding. You can point to it by saying words like category theory or monad. But what structures are we actually understanding? What is the sort of semantic label that we should be putting towards what we're doing? So I think in the end, it can be made, category theory can and will be made much more accessible than it is presently. We see, I mean, one reason it's hard to explain is because it's different from the ways of mathematical thinking that are prioritized by the education system. You know, you maybe have a discussion about hiding differential geometry, maybe not. But one thing that's different about differential geometry and category theory is that the whole sort of high school and college syllabus is leading up to it in a way that's not true of category theory. I think to fix that, we need to think about the ways that category theory can be integrated in the education system all the way through from sort of the primary or secondary schooling level. And I know there are a bunch of people thinking about this. I know Bob has a textbook, I hope I'm allowed to announce this, in the works for high school students around categorical quantum mechanics. There's work, for example, by Eugenia Cheng, really trying to explain category theory to a completely non-mathematical audience, and I think that's excellent. I think one project that we're working on at Topos is building community around projects around informal education. So environments, say computational environments that reflect categorical structure, where you can get an idea of how to think categorically without necessarily learning, you know, the axioms that define a monoidal functor. And I think all of this will be significant in the years to come.
Thanks, Brendan.
Oh, sorry. I think there is a nice example in what I said earlier, that IBM now thinks that ZX calculus could be the way they think it themselves to teach quantum computing at high school level. So here you have an example where is the category theory is not the hurdle, but it's actually the vehicle to teach something complicated like quantum computing. So where I see the essential thing is that when we did categorical quantum mechanics, we tried to use compositional structure to make category theory part of the world, rather than some piece of mathematics that lives out there. And maybe a little bit more of that should be done. Like category theory has been too long in the hands of mathematicians. I know some people are going to hate me for saying that, but I think that's very true. And that's part of the problem now.
If I can elaborate on that, you know, in our experience at Conexus, where we go and talk to very smart data practitioners, you know, they just don't know category theory or database theory, but that doesn't mean they don't know their domain very, very well, you know, far better than we can. So I think, you know, the community may want to focus on what it can learn from the applied domains, as opposed to try to push the structure of category theory onto them. That, you know, we should all try to the application should be more in the learning than in the pushing of the math towards the engineers. That's all.
Yeah.
Yeah.
Jelle, you had a comment?
Yeah, I thought I maybe should say or mention that I found that if you can actually play with it, let's say it's like a toy, you can see it in your hands, you can manipulate it. We don't really need to explain that much. I can give you a paper about Petri nets or analogously, like group theory versus an actual Rubik's cube. You can play with the thing and you can start understanding the rules. And I think that gives a much better understanding. So I'm quite convinced we will get to a stage where the tools are slowly getting more and more things in. It starts with products and co-products and maybe diagrams and so on. So I'm quite optimistic about getting it out into the bigger audience, because everybody wants to use wiring diagrams when you are using wiring diagrams. If your system, then you would like to use it. It's simply the clearest way to do it. It's nothing vague.
So any more contributions? We'll have to wind up pretty soon. Yeah.
Great. So me again. I just wanted to revisit what we were talking about what category theory means to lots of different people. So I think from where I'm standing, it seems like to some people it might mean ZX calculus, to some people it might mean Petri nets, it might mean some fancy stuff with cospans. But really, I think of category theory as definition of a category, something about a functor, something about natural transformations, maybe some adjunctions, in the way sort of like a practitioner of mathematics who's maybe doing lots of linear algebra, sure, maybe their work is justified by ZFC set theory, but I don't think they would consider themselves set theorists. So by what logic do we really, so is there a line where the things that we're talking about stops being category theory and starts becoming more of a specific thing which is nebulous? Because you can say, yes, everything's category theory because it composes, but at some point you're so far away from what category theory means to a lot of mathematicians, and it's not like their views are completely invalid, that you're talking about something completely different.
What you're saying is category theory is a way of life, Nick.
Yeah, I think of it as like a field of mathematics, but to some people it's a whole lot more, it seems. Yeah.
Okay, I think we're gonna draw to a close. I'm really so grateful to all of our presenters, Phil Wadler, Bob Coecke, Brendan Fong, Dan Geeker, who was here with us briefly. Unfortunately, to get a chance to speak. We'll hear from him next time, I'm sure. Jelle Herold and Ryan Wisnesky, and all the comments from the local audience and the virtual audience. That was a really great, interesting session. And let's thank everyone again for their contributions. Okay, so now we're logging off. Thanks, everyone, and see you tomorrow.